Okay, so in this section here, we're going to be talking about, this relates to chapter 9 in the book, and it relates back to systems development and project management. Basically, the areas we're going to cover, the two areas that really kind of make up this space. One is this idea of developing an enterprise application, this idea of what we call a systems development lifecycle, and some of the different approaches that make up a systems development lifecycle. And the other major piece that's in this chapter, we talk about project management. So basically, it's the application of project management techniques and approaches to deliver a successful technology project. All right, so talking about both of these. Um, Software development lifecycle is also known as the term that gets used is SDLC. Um, is really a process by which organizations have developed a set of best practices for be able to develop um, quality software. So it would probably be the term that we want to use: high quality software that does what it's supposed to do and performs as expected and is reliable, maintainable, supportable. All right. So um, the challenge is that writing software is usually very hard. All right. There's a definite risk factor associated with software development activity. So what happens is, the risks involved would be things like, for example, impact on revenue, uh, brand reputation, liabilities. Basically, a lot of not good things can happen when involved with developing software. So, the idea is that you want to be as effective as possible in your software activities. So, the SDLC, the idea of an SDLC is really a set of tasks that's been outlined that really kind of outline, they describe what would be a series of best practices, a series of steps that organizations should go through as part of a software development. All right, so this is the cycle. It is as we call it. It's a life cycle. All right, so it's really some, a couple core steps to this. Kind of start off with the idea of a planning, trying to figure out a project initiation, trying to figure out what you want to do. Who are the stakeholders, and what are they trying to accomplish? Right, it's kind of initial planning step. Coming from the planning step, you go into an analysis phase. One analysis phase is you'll go through and evaluate, the feasibility of something. What are the parameters? What are the scope? How many? What precisely is involved with, what developing the requirements for um, this application or software that's required or desired. Um, Next step after analysis is design. So design, takes what the work that's done in the analysis side and actually does a design. Kind of mocks out, basically the details of, how it should work. Um, Around this, calling out specific details around interfaces and, what data, what data files or databases should look like. That's all covered as part of the design. Um, Development, once again, follows from design. So once you've completed the design and have reviewed it and have signed off on it, then you move into what we call the development cycle, which is really the programming side of things. A lot of times, what will happen is a lot of organizations, the programmers have a tendency to assume that these first three steps are overhead and that you go directly to development. But really, there's a real need. Successful projects will have a discipline associated with it, which says, okay, well, you plan, analyze, design before you develop. All right. Once development is done, the next major piece is testing. So whatever you write, you verify that that it meets the requirements that are defined in the design, and derived from the analysis. It meets those requirements. It does what it's supposed to do. It doesn't do what it doesn't supposed to do. So testing is actually can be very involved. So doing good testing and quality testing is very important to be successful. Um, Next major piece is implementation. So implementation is, the taking of that particular software solution, whether it's a single program or a set of programs or an application, and putting it into use. So sometimes this will be, depending upon the situation, this could be fairly straightforward, or it could be very involved. For example, like an implementation of an ERP system, or a large scale system takes a lot of work, a lot of coordination of different activities, training, um, things of that nature. All right, so but implementation is really needs to be addressed as a set of activities all unto themselves. Um, Once a system has been implemented, once it's in operation, the next major piece is really kind of the ongoing support of that application. So what we call maintenance. So what will happen is things will be found, bugs will be found, the things will not work exactly the way people want, or circumstances, business circumstances will change, requiring you to modify the program. That's really where this maintenance comes in at. All right, and then over a period of time, what will happen is uh, eventually as time goes on, you know, the the next generation of the program, you want a next generation application program. Basically, you start the cycle over again. Go from a planning, analysis, design, development, testing, implementation cycle. So that's the life cycle. So there's these one, two, three, four, five, six, 7 steps. Right? There's a bunch of different ways to do this. So we have these 7 steps. We have these 7 steps that make up the SDLC life cycle. Um, there's a lot of different what we call methodologies to be able to use these things. All of these will encompass those 7 steps, but each one will do things a little bit differently. So if you look at each one of these, and we'll talk about this in a sec, but as you look at all of these, each one of these will have all of the different phases. You'll have aspects of design and development and testing. All those different pieces will be incorporated in this, but where they will differ will be the sequencing and how things are organized, of the sequencing of tasks, the organization of tasks, how things are approached are different. But if when you boil it all down, the life cycle itself, the 7 steps in the life cycle, basically will always, will be present in each one of these. Uh, First major technique is something called waterfall. All right, so basically what a waterfall is a series of tasks which are executed in sequence, in which the output of one task becomes the input of the next. All right, so as we look at this, we say, we look at planning as having being a project of a fixed length with certain deliverables, which they are then fed into the analysis phase, which will have, also run a series of processes, which will then have a series of deliverables, which will be fed into design, into development, testing, as we go through. So the idea of a waterfall, if you kind of look at the pattern here of kind of one going from one to the other, right? And the idea is that each task is completed and then passed to the next, and then passed to the next, and then passed to the next. This is how this is works well in like the construction of buildings, and this actually was adapted. Has been a pretty significant techniques that's been used in software. One of the challenges, though, and we'll talk about some of these other ones in a second, waterfall does work, but it doesn't work to as well as would be desired. So what happens is writing software is different than building a building. Right? And it's we use the term software engineering, but I think one of the things that as we've looked at and as we've have created different techniques around software engineering, what's been discovered is that this straight linear approach, a lot of times the straight linear approach does not always work best, because a lot of times in these early phases in the planning analysis, the idea of what is actually needed, what is desired, is not clearly understood yet. So people don't understand what they don't understand until they see something. So a lot of times, what will happen will be you can get multiple, to go through multiple stages and through the development cycle, and suddenly realize that this may not be, um, what you're looking to do. It's just the solution you're working on might not be the one it's going to meet the requirements, or you might not discover that until actually you get to the implementation phase. All right, so that's one of the weaknesses of the waterfall. I mean, the waterfall, it's very good in terms of being able to, it applies a level of discipline. It enables you to manage and track costs and things of that nature. Problem is, from an actual development cycle, it assumes that you can just move this stuff in a straight linear fashion, and what experience has shown us, software a lot of times does not match exactly up with that. Which leads us to what we call agile. So agile is actually this idea of doing interactive or iterative development. You do as a series of tiny projects. So instead of trying to write the whole thing and doing it in a series of sequences, what you do is you actually will create an early prototype. You kind of create a first cut at something, and then look at it, evaluate it, and then build upon that. So the idea is you do kind of a continuous development activity. You kind of do an early, you're doing, and actually the other thing that's noteworthy about agile, it also assumes very tight customer engagement, whereas with waterfall, a lot of the customer engagement kind of gets handled in this stuff right here, and then from this point on, it's really kind of a hands-off. In agile, the stakeholder, the customer, is involved really the whole, through this whole life cycle. All right, so it's the idea of kind of building it and then building it, and building more of it, and then building more of it, and building more. So it's really what we call this iterative approach. RAD is another technique. The idea of RAD is that it uses it has some similarities to what with agile. Extensive customer involvement, evolutionary construction, the idea of developing prototypes, working prototypes, and then building and enhancing and elaborating upon those initial prototypes. All right, so the idea is this analysis phase, you develop a prototype as part of the analysis phase. So the idea is that people can actually see a working version of something prior to committing the full investment of effort around the application development. Extreme is another variation on this. The idea is it takes a project into tiny phases, and you kind of do a continuous iterative process of you do a one phase, and a subsequent phase, iteration 1, iteration 2, iteration 3, iteration 4, as we go through this. So it's simply another example, another variant of this kind of repeated approach, kind of building things in across a series of stages. RUP is kind of is kind of sits between agile and waterfall. It breaks down the development into 4 gates: inception, elaboration, construction, and transition. Once again, this kind of this elaboration and construction. It involves a lot more, a greater degree of engagement and development of, prototyping type of applications, and kind of, building something, looking at it, evaluating it, coming back and improving upon it, and continuing to kind of move ahead around it. And then Scrum. So Scrum works very closely with Agile. So a lot of times Scrum is a technique used within Agile. Uses small teams to produce small pieces of deliverable software using what we call sprints. A sprint is defined as a 30-day interval with a specific goal. So what will happen is each day, the team. So the team is actually made up of both developers and end users, and there's a particular techniques that are involved within Scrum around orchestrating meetings, beginning of the meetings, end of the day meetings, tracking, monitoring, communication, feedback, all part and parcel of once again, building things on an incremental basis and adjusting as you go. So you avoid the total commitment up front, and you basically develop it as you go along. So this idea of project management. So this idea of project management comes hand in hand with these SDLC um, techniques, because really you know, the idea of project management is, you're managing resources, you're managing time, you're managing scope, you're managing the different pieces of the project to an endpoint, and project management in different forms. I mean, it really has become kind of a core capability in software and software development. All right. So a lot of the things we see, project failure, when you go back and you retrofit, or you go back and evaluate why projects failed. Missing requirements, skipping phases, this idea of scope, feature scope, project scope, adding more stuff to more stuff as you're going along. Failure to maintain the project plan. So these are all things that have been identified. So the disciplines associated with project management is really designed to ensure that tasks are completed, things are verified, all the phases are completed and verified and signed off on as we go through. One of the challenges with what has been found within SDLC in projects is the later you find the error or a problem, the more expensive it is to fix. All right, so as we move along from planning and analysis, an error detected fairly early on can be corrected prior to development. So as you see here, is once we get into the development and testing cycle, we really see an acceleration as we get into through the later phases, an acceleration of the cost of correction. All right, so the dollar cost to. So the idea is you want to be able to, your project management is, designed, the different project management techniques involved with software are designed to really kind of track and manage and identify, the different types of variability, and trying to define errors as early as possible and ensuring that things are corrected, as soon as possible, rather than have it roll down and have having a much higher cost to modify. So some ideas, some numbers here. $1 trillion in MIS projects. Over on a global basis. I don't know. The book says 70% will be lost. I don't know if that's 100% true, but you see a lot of times, that a lot of things projects will, a lot of way projects will fail is, they will go longer than expected. They will not deliver what is expected. Not every project will fail 100%, but a lot of times you'll see a lot of rework, a lot of inefficiencies around projects, and you see a lot of the consequences, around damaged brand, lost goodwill, uh, lost investment opportunity. So there's a real, a real level of urgency involved with making sure the stuff gets done and gets done right. And there's been a growing understanding of the level of risk associated with software and software development activities, and trying to make sure it gets done correctly. So in the project management field, the thing, project managers are basically working around something we call the triple constraint. All right, so this idea of a triple constraint is, as Ben Franklin had said back in the day, that if you're failing to prepare, you prepare to fail. So that's kind of it's a well-known maxim, but it is true. And it actually is true. I think as you see, the planning parts of projects are are very important. And the uh, in addition, the project management, the thing you run into with project management, as we look at project management and the way project management is implemented, um, these types of tasks, the stuff we identify, the stuff we call out, the stuff we operate on, um, all of these, they have become kind of something that's managed and tracked and evaluated. So you see a lot of, but you'll see a lot of these, trying to make things more efficient in terms of project, and you know, deliver getting better outcomes from your effort. So the triple constraints, we talked about the triple constraint. There are really project managers who are dealing with basically three types of constraints. All right, and so obviously at the core, project managers are responsible for managing the expectations, for all of the stakeholders and coordinating activities across all of the different resources. The constraints the project managers deal with are, time, resources, and scope. Right. So those are the big three: time, resources, and scope. And what happens is the triple constraint. What the triple constraint means is that um, basically you can really only, one of the challenges is you can only focus on two of these constraints, you know, with the detriment of the third. So what will happen is, um, if you're managing time and resources, you have to be, the focus will be on scope, the challenges you're going to have in scope. If you have time and scope, you're going to need more resources. All right. Uh, if you have resources and scope, you end up having to deal with, a longer time. So the idea is you can't manage all three equally. All right. So what will happen is a lot of times project management is based upon kind of a balancing these things out. Balancing the limitations of both time and resources and scope. Because quite frankly, you do not have all these things are not. These are limited. You only have limited amount of time to do things. You only have limited resources, and there should be a fixed scope of what you're going to implement. Because obviously, if you keep changing the scope, people keep adding requirements and doing and adding stuff to it. You just keep going and going and going and never get to an end point. All right, so some of the terminology we use around project management, there's a project. Project is defined as temporary activities undertaken to create a unique project and service. All right, so the key concept of project is it's a temporary construct, of people working together, targeted for a particular outcome. All right, project management, is a set of knowledge, skills, tools, techniques, to apply to project activities to meet requirements. All right, so that's really what we define project management. And then the project manager, who is a person who is basically the user of these skills, an expert in, the different techniques, management, responsibilities for, the project plan, tracks the plans, make sure that the project is completed on time, on scope, to meet expectations and operate within, what's defined as the project scope. So this is kind of an example of, of a project plan. It's kind of an example of, very task oriented. As you see, kind of different phases over time, with resources. And this is, on the Gantt chart side, which is basically kind of a pictorial view of a project, with the allocation of resources over time to a particular project for a particular outcome. Now, one of the things we've seen probably over the past 20 years is this idea of outsourcing. It used to be traditional IT organizations, everything was done within house. So if you're in the mainframe world, a large portion of what was happening is, you had the programmers. You bought a computer, you had your internal staff manage the computer, you had your internal staff develop the software and run the applications that ran on the computer. All right. So, within the organization, so traditionally that was a pretty well established, pattern. All right. Now, what we saw about maybe 20 years ago, we kind of saw the rise of what we call outsourcing in the IT field. So it's an arrangement when we define it. Definition of outsourcing: arrangement by which one organization provides a service or services to another organization that makes a decision not to perform them in-house. So it is a shift. It's an organizational shift, so that instead of the IT function being 100% staffed in-house, um, you know things like, for example, that like help desk or PC support or other types of things are actually turned over to an outside organization, which may have more expertise around that, or can maybe leverage things like economies of scale around support, and be able to do things at a cheaper price. So we've seen this. This has really been what we've seen over the past 20 years. It's really been kind of this whole, I think you look at a lot of organizations now, you'll see kind of, you would have seen over the past, 20 years or so that, there's a lot more emphasis on outsourcing, much more utilization of outsourcing around different IT functions. So some of the stuff, around the cost, obviously, at one point, it was the idea is that if you outsource it, it's cheaper, which can be, but it's not an automatic, or a lower cost around outsourcing is not an automatic given. All right, so it has to be managed correctly. What you have to identify what is to be outsourced, and then being able to manage the outsourcer effectively is going to be a key factor in the success. But some of the stuff we've seen is core competencies, the ability to kind of reach out to organizations, especially with more sophisticated technologies, and not having to hire people with that level of with deep levels of technical expertise, kind of bringing them in as needed. So, when it's done well, you see, financial savings. You, a lot of times this stuff can give you the ability to respond quicker and react more quickly to circumstances. You can add more resources as opposed to having to staff up inside. Um, the other thing is really has been a big driver is this idea of globalization. So globalization is really kind of it's really kind of plugged in with outsourcing. The two of them are kind of seen as almost you know uh, the same. They're a little different. I mean, they're not exactly the same, but the idea of globalization and outsourcing, we've seen a kind of a combination. They kind of work hand in hand, where a lot of the resources, technical resources that are involved with outsourcing, are offshore in different countries with different, basically resources on a maybe a lower cost pay scale, which can be leveraged for a lower cost of execution and operation, and the ability of the internet to be able to provide connectivity, cost-effective connectivity between country to country without a lot of overhead. Has also kind of moved this stuff along quite a bit. Just some idea of kind of some, this idea of inexpensive good work. You have high quality staff, but being able to do it, at a much more cost-effective range, as opposed to trying to build all this resources and staff in house. So the benefits, if it's done well, you can increase quality and efficiency of processes, reduced operating expenses, particularly with headcount. It's taking, it's fewer internal staff with the overhead associated with internal staff, and you'll be able to maybe reduce a bit some of the, exposure with large capital investments. All right. If you have a good working relationship with an outsourcing partner, you can actually leverage both their expertise, their economies of scale, best practices, and times. The really good outsourcing arrangements will have this, but once again, it's not always a guarantee. So there's a lot of work that has to be done in order to make outsourcing work um, correctly. And what's happened is you've seen a lot of situations where organizations will do an all or nothing proposition. So what they'll do is they'll outsource 100% of everything. And then all of a sudden, when things, if there's an issue or things don't work exactly what they expect, they go the other way and try to bring everything back in house. The reality is there's probably going to be more of a balance between there are some things going to be insourced, there's some things going to be outsourced. And that could change over time. The ratio of one side to the other can change over time. So it's not either going to be, not all of one thing or all of another. So I think that you've seen organizations have kind of moved more to a balance of having, okay, you're going to have an internal organization that's going to be staffed with resources to do, key tasks, key activities, manage uh, key resources in the organization, and then those will be complemented, supplemented with outsourced resources as needed. So you can scale that up, scale that down, which gives an organization a lot more flexibility. The challenges, there's a lot of challenges with this. So not every outsourcing contract has gone as expected. So you've got things like the length of the contract, getting things, getting in and out of the contract, identifying, all the different projected activities. A lot of times organizations will think they've got their arms around the scope of something and discover much to their horror after, the contract is in effect that, the costs are actually being, instead of being a lower cost, it actually becomes a higher cost. You know, there's things around if you were to outsource things that really you're leveraging for your competitive advantage, that could be a problem. So a lot of times what organizations really focus on, what are the things you need to maintain and sustain a competitive advantage in your organization, and the stuff that does not have any ties to your competitive advantage, you could outsource that. So if you kind of look at um, the model, Porter's model, where we had talked about kind of um, the value chain, which are really the core activities, and then the supporting activities. There might be more inclination to outsource things around the supporting activities as opposed to activities or things that are in kind of in the value chain itself. And finally, this idea of you're by tying into somebody on the outside, whether or not you can maintain and sustain confidentiality of key items and key things. So there's a lot of thought that has to go in order to do this and do this well. It has to be really planned and planned out, thought out well, and then adjusted as needed as you get more learnings about things. And that really is it for chapter 9.